Hello, I'm going to talk about some ideas and some implementation of Cerebral2. So this is just the initial work. There's still some things to do, but it's going surprisingly fast. So it shouldn't be that far away, actually. So let's talk about some of the things I suggest we change. First of all, I want to simplify the API. I think it's, even though the concept of Cerebral is simple, the API doesn't really reflect that. So I want to simplify it so it's very, very easy to get going. And then I think we should have a monolithic repo. We have lots of repos now where we have different linting rules, building rules, just installing, get going. We needed a CLI to make it easier, and that says something about the complexity of all the repos. And also the really pure thing that came out of the Cerebral project so far is function tree. That is like what's different, that is what is really helpful compared to other projects. So actually I started implementing function tree in the current Cerebral code base, but then I realized that's not really a good idea. It's better to create a completely new Cerebral as a wrapper around function tree, and then bring in the functionality that works now with Cerebral and redefine the API. Not completely different, but make some adjustments. So what we're going to do now is that I'm going to do a demo. So how this would be introduced to developers, because I think there are lots of terms and things we kind of throwing very quickly at new users now, which makes it confusing. And then I'm going to show some code of Cerebral2. It's been insanely simplified, so it will be a lot easier to contribute to the project. And then we'll finish it off by talking about some of the specific changes. Okay, so this is an application, hello you, and when I click the button, it changes to hello everyone. And this is a typical React application where we have our component, which is a stateful component, and it has the title, and it has a method for changing that title. And then we have the UI down here. So what we want to communicate with Cerebral is that we don't want this kind of stuff. We don't want state inside our components, because the only the only component that can access this title state is this component, or it will have to pass it as a prop down to other components. And this creates a messy code base. It's very hard to understand the relationships. But that's not the only thing. The other thing is that if you want to change this state, that can only be done from inside this component. So if some other component need to do that, we would have to pass and it's just not a good way to do it. We want an abstraction over this so that we can keep our components completely pure. So the way we do this with Cerebral, we're going to refactor this now, is that we bring in the controller of Cerebral. And the controller is just something we instantiate. And we want to put this title state into the controller. Hello you, like that. So when we save this now and we refresh our application, you instantly see some benefits. Like with Cerebral, now we know that we have this state available because we see it in the debugger down here. To make this state available to our component, we have to import a container. So Cerebral is view agnostic, which means that you need to expose the controller differently for different views. So with React, we do it like this. We have a wrapper container for the whole application, and we give it a controller. So if we refresh now, there's actually no difference. So what we need to do is go into our component and we need to change out some things. So what we'll do is we'll keep the rendering of the component, but instead of creating a class, we are going to use something called connect from Cerebral React. And when we connect, the first argument is what state do we want to extract from our state store and inject into the component. And what we want is the title. So we point to the title. And then we can render the component. But instead of using a class, you can still use classes, but we don't really need that here. We can use just a plain function that gets the props. And instead of pointing to state, we will now point to props. And since we can't really do anything on the click yet, we'll get to that very shortly. We'll just remove that for now and save it. So when I refresh now, it still says the same thing, but I can't change it. And if I go into to my state here and say hello Cerebral and change that, we can see that it has updated. So now we are using state from our state store instead. And the point now is that any component can just connect to that state. It doesn't matter where it is in the DOM structure or the component tree. It can just be injected anywhere. So let's now see how we would change this title. And the way we do that in Cerebral is with signals. And signals are not functions, they are function trees, which means that when I name this button clicked, we will use an array instead. We define a tree. And basically what we want to do here is just change this title. So I will create a function in here, which I call change title. And since this function is inside this function tree, it will receive an argument called the context. But on this context, we are going to extract the model. So on the model, we are going to set a new title to hello everyone, just like we did before. And when I save this now, I can also inject signals into this component. So that will be a second object. So let's just call it button clicked and grab button clicked. And we will on click, we will run props button clicked and save that. When we now refresh and I change the title, we can see that it changed just like before, but we also see what actually happened. So we see that a button clicked signal was triggered and we see exactly what state change was done. And we can see in the state tree that it changed. But the thing is now that any component can do this. Any component can grab this button clicked signal and it can change the state. And that will affect all the other components. So the thing is that this is insanely scalable. You will never get into a situation where you have locked in some state or some component can't make the state changes you want. Yes. Another thing is that you can move these components wherever you want in the component tree because they specifically depend on some state and some signals. And it doesn't matter where they are in the component tree, so you can very easily move them around. Okay. But what if you're going to build a bigger application? You need to kind of structure all this state and all these signals. And for that, we can use something called modules. So instead of having the state and signals here, we are going to use a module. And we'll call that demo. And let's say demo module. And we'll import that. Import demo module from modules demo. Okay, so let's take a quick look into that. And as we can see, this is just an object as we had before. And it has the state and it has the signal. But instead of defining it directly into this definition here, we point to something we call a chain, which is called change title. And instead of using a function here, we are using an operator from Cerebral, which allows us to do state changes and other things directly in these chains. So we point to like demo title, because now the namespace is demo on the module. So it's the demo that has the title. What we also need to do now is change where we grab the state from, because now we grab it from the demo module, both the state and the signal. So we save that, and when I refresh now, we can see that the state tree has changed. Now it's under demo, and when I click, we can see that it's the demo button click that has been triggered, and it's setting state on demo. Okay, so this was like how we could demo Cerebral to others, and I think this kind of like nails it. This is what Cerebral does, and we can take a normal React project and we can convert it to a Cerebral project, and then you'll kind of like instantly see the benefits of it. So what I would do in the demo initially when changing to Cerebral, I would actually click here and change the state here, but that's not working at the moment. So yeah, just need to fix that. But I hope you see how much more powerful this becomes. So yes, let's go in and look at some Cerebral code here. Cerebral. So now we have the index file is currently just exporting the controller, but here we will have like computed, we will have the router. So the router is a core concept of Cerebral. You don't have to use it, and we can use like tree shaking in Webpack 2 and all this good stuff to avoid including it if you don't use it, but it should be there. Yes. So the controller is now, and this is a thing, like I don't like classes, but when I build libraries, classes are really good. They're a good structure for building libraries and APIs, but they're not good for building applications, I think personally. But anyways, it's not much code there. It's basically just firing it up, instantiating the debugger, setting the model, which now has, Cerebral has a default model, which is basically just an object. And I think this will actually work for like maybe 80% of the projects, because we throw these words like immutability and all these like references and all this stuff, and it's very difficult to understand it. And it has some bad parts to it as well, like speed and that stuff. So I think it's better to just let people get into it and start creating things. And since it's such an explicit API for changing state, I don't think it will actually be a problem. I think the benefit of just getting going is so much better than making these, adding these terms and yeah, just making it more difficult to understand how it works. But of course you can bring in your own model, like an immutable one or whatever, and it works the same way. Okay. But then it creates a module. So there's like a top module, and it brings in the state define and its signals and its submodules and providers. So providers is like the new hook. Instead of having services, and basically it's instead of having services, because now we're using function tree, and function tree already has a hook, and that is providers. And providers allows you to do whatever you want. You can add, let me give an example here. So if I wanted to provide, for example, Firebase, I could say providers and Firebase provider and all the config here, config. And this would add Firebase to the context of any function, allowing me to talk to Firebase and all this good stuff. If I wanted to just attach, for example, Axios, I could just use an object here, and that would use the context provider from function tree and just add it, and it will work with the debugger and everything. And the really cool part there is that all these providers has nothing to do with Cerebral specifically. It has to do with function tree. But you are very much welcome to create your own function here, which will receive the current context. It will receive function details, which is like which function is running and all that stuff, and then payload. And this is based on function tree. So you can attach whatever you want here. And you also have access to like context.controller. So you can do anything you want here really. But the point is that initially you don't have to do anything to get going and understand Cerebral. Okay, so if we go back to the code here, we see that it fires up all the providers. So it has some development providers, which is the debugger provider and stuff like that. But basically it adds the controller and it adds the model. Yes, and then we have the module. So again, this is pretty much all the code for Cerebral now. It's kind of crazy. And what the module really does is add some initial state to the model. It has a list of the signals, and it also has that is where the providers actually get used. So like a module, there's a top module which has like the initial providers, and then if you define providers inside a module, a submodule, and so on, it will inherit all the providers down the chain, kind of. So you can have one submodule which has some specific providers for this for the signals that runs in that module and stuff like that. So you have all this kind of cool stuff. But the thing is that every module has a function tree. So this is where the signals run. So each module has its own function tree where any chain, so to speak, can be run through. And when that chain is run through this specific function tree for this specific module, it will use the providers defined for that module. This is low-level stuff. You don't really think about it, but that's how it works. And then it will register any submodules, and it exposes a method for running a signal on this module. So there's no connection between a chain and the modules. The modules just defines a way to run chains specific to that module, and it has some signals attached to it. But technically, any module can run any chain with their defined context providers. Okay, and then we have the default model. Also super simple stuff. It's just some state, and whenever we change the state, which now only supports set, but I will extend this, of course, it uses this update in method. So you get a path and a value, and this is the same for all the other methods as well. It will update in, and when it does that, it will push the path that you're making a change on, and it will add that to the flush. So this is what happens when you change state. It flushes out what paths actually changed. Yes. So that's basically what the model does. It's very little code, as you can see, but it's super fast, and it's super fast. So what's also been done here is remove normal rendering. It's only strict rendering now, and it can be a bit when you want to refactor from non-strict to strict. It can be a bit like it runs differently, but the thing is that strict mode is way faster, and it's more like it kind of like builds up on this concept of only grabbing the state you need, only grabbing the signals you need, and it will only render when it needs to with strict mode. so that's also interesting because there's so many performance and benchmarks and all this stuff, but nobody can do what Cerebral does, as I know of, and that is to render the exact component that depends on the state. There's always like unnecessary rendering going on, because if you make a change there, and then you have to render all the parents and all the children. But now we can control that completely. And it's a very simple API for it. It's the star stuff, if you know about that. Like if we did, for example, this, it will only render if actually demo changed. But if we did dot star, it would change if any of the properties within demo changed, or star star, it would change if any nested whatever changed inside demo. So it's quite simple, and it's a lot easier to use it when you do it from the beginning instead of refactoring an existing project. Okay, I think that was enough about code. And yeah, as you can see, the operators are here. React and Inferno would be here as well. So you have everything in this one project. Yeah, so to sum these ideas up, there is no more imperative controller module API. As you could see, there were just objects that define state and whatever. That said, if we take a look at this module here, you could still do this. So you get the module, and the module is the module instance, and then you have access to everything. You can grab its signals, you can run signals on it, you can grab the controller to get all the signals, and the model, and whatever the heart, what's it called? The heart, not requires, but it wants, or whatever. Yeah, you know what I mean. But you don't have to. And usually you don't need it. So that's the thing, like we're making it super simple now for people to get into it. And when there are special needs, then you can kind of like open up the more complex stuff. And there's no more immediate signals. Now there's only signals. That was a completely pre-optimization thing that hurt the API quite a bit. And also getting into Cerebral, it's super weird that you have this immediate thing. But usually you just make a small state change, or then you run something asynchronously. So it doesn't affect like this. There's no reason to use request animation frame and stuff, and nobody else does that either. It just makes the APIs a lot more simple. And then the extension hook of Cerebral, it doesn't have it really. Well, you could still create a module, for example, the user agent module, put stuff into the state tree and has some signals it uses. We can still do that, of course. But if you want to extend something on the context for the functions, then you use a provider, which is basically function tree. So you think of it as like a function tree thing. Not necessarily specific to Cerebral. And then, of course, having a monolithic project, one repo with the debugger, the router, the view connectors, and the operators, and all this stuff. Have it in one project. They follow the same styles, and they have the same test approach. And as you can see, I'm writing everything using Webpack with ES 2015. So we have all of this stuff inside one repo. Okay, so I have a bit more work to do, but then I'll create a branch on Cerebral, and I will also create a README and link to the new debugger, because it's a completely new Chrome extension. Because that's also one thing we learned during the process of Cerebral 1 is how to communicate correctly between the browser and the Chrome extension. So we need to create a completely new extension, actually. Okay, I think that's it. Please let me know what your initial thoughts are. I did not go into much of the function tree functionality, but that is because it works just like function tree, so you can check that out. But yeah, I wanted to talk about the overall API instead, and the entry point. How do you get to know Cerebral? Cool. Hope you liked it, and I'll talk to you later.